Hello guys, this is Ammar Ona. I'm gonna help you today to solve the Burhan Numerical Analysis exam. And this is Claudy is saying hello to you. He's gonna help us too. So we're gonna start with the first question, which is the secant one. You know the secant formula that gives us a new point, and we have a previous point in a point previous to the previous. So if he gives you the previous point and previous, which is our x0, x0, or x1, these two, then you're okay. But if he doesn't give it to you in the question, he will give you, by the way, this equation. You're just gonna plug these points you just like chose randomly and see if they are multiplied together less than 0 or not. If they're less than 0, then yes, you can use them as initial points. After that, you just apply these points to this equation and you get xn plus 1, and bam, you got this one. And then you calculate the approximate relative error, which is the new estimate, okay, minus the old estimate divided by the old estimate times 100 to get it in percentage, okay. And if you do this, as I told you, you're gonna get 300%. Then in the next iteration, this point becomes this, and this point becomes this, and you move on until you reach good percentage, okay. He could mention like 5% or less in the exam. Here, since we were 21%, then we are going down, okay. This is convergence. Then when we reach this, we went up. So this means it's divergence. There is no solution, so we stop. We choose another two random points, which is -2, -1. The f of them in this function is less than 0. Then okay, we're gonna start to solve until we get a good percentage. This is basically the secant method. In all other iterative methods, he can like make up a law for you and call it Trapp's law. He can use the fixed point iteration or whatever. These are pretty easy and solved everywhere in the YouTube, so I'm not gonna explain other methods. I'm gonna just go through the exam. After we finish that, we got this thing, Navy-Gaussian method, okay? You basically get this system of linear equations. You get the coefficients of each x, y, z, and you put him here, 2, 2, 2, minus 1, 2, 3, 4, and their results too. After that, what you're gonna do? You're gonna make this 0, make this 0, make this 0. By using the matrices rows rules that states that okay, if you multiply rows, if you swipe rows, if you add row to a row or subtract row to a row, it will be the same. And this is actually because this is an equation. So if you add equal numbers to the equation, it will not change. It will be the same equation. So how we can do it? He didn't mention here partial pivoting. So be careful. If he say partial pivoting like this question, it's something different, okay? So what we're gonna do, first thing, these things called pivot. This diagonal line, the 2, the 3, the -4, called pivot, okay? So we want to make 2 as a 0, okay? We're gonna look to the pivot above it. We're gonna have something. I want you to note this. This actually, I got it from Claude. I'm gonna just pause the video and write it for you. So basically you have this row, target row minus multiplier times the pivot row. What does this mean? Okay, we want basically to do some operations on this row to get this 2 to be 0. Okay, we start from this one, get it 0, then move to this one, then move to this one. The order is important. What we are gonna do here is we are gonna take the target row, okay, the row we want, which is this one, 2, okay. I'm just gonna get down, sorry, this messed up a little bit, I don't know why. Okay, we're gonna take this row, which is row 2, okay. this row 2 is gonna be subtracted from the multiplier. What is the multiplier? Okay, the multiplier, guys, is basically this. I'm gonna explain it to you. The multiplier is basically we are trying to make this 0. Okay, we look to the pivot above it. The pivot above it, we said this is called a pivot. Pivot, pivot. The pivot above this number is 2. Okay, the multiplier is the number we are trying to make 0 divided by the pivot. That's it. 2 over 2. A11, which is this one, the pivot, divided by A21, the thing we are trying to make as 0. So this is the multiplier. So it's going to be row 2 multiplier, which is 2 over 2, subtracted from multiplier 2 over 2. And we, as we said here, the pivot row. Okay, the pivot row, which is actually row 1. How we know pivot row? What is the pivot now? We're making this 0. What is the pivot, the number above it? Okay, this one. So we're going to use pivot row, which is row 1. So that's what he did. He said, okay, I want to make, let's delete all of this. He said, okay, I want to make this as 0. Okay, so I'm going to check the pivots above it. Oh, this is the pivot. Okay, I'm going to say the number I want to be 0 divided by the pivot. 2 over 2, which is this one. This is the multiplier. Multiplied by the pivot row, which is the first row, which is this one, which is this one. So 2 over 2 is 1. 1 multiplied by the row is the same, so nothing changed. Now subtract row 1 from row 2 that we are trying to make 0. This is it. Okay. Wait, my bad. It's the other way. Row 2 subtracted from row 1. Okay, this is row 2, this is row 2, row 1, row 1. And bam, you got the first 0. Let's go. Now you move on for the second one. You're trying to make this 0, 2 in this order. Okay, what is the pivot? Okay, we have these 3. What is above this is this. Okay, so this is the pivot. So you're gonna say minus 1 over 2, minus 1 over 2, pivot, and the number you're trying to make to 0. Okay, multiplied by the pivot row, which is the exact first row. So it's the same. Okay, so you multiply by minus half, you get minus half for everything. Then you say, okay, the row 3, which is this one, subtracted by row 2 after we modified it. For the row 1 after we modified it, which is this one. Okay, this one. You subtract it and you get your second 0. All right, in the second step, now we are trying to make this one 0. Now the pivot has changed. Our pivot is 5. So we are gonna divide by 5. 3, 3, 5, 5. Okay, A22, this pivot. And we are gonna choose now the second row, okay? Because it is the pivot row, as you can see here, the second row. And when we choose the second row, which is the pivot row, to multiply by the multiplier, this is the multiplier, this is the multiplier, this is the second row, we are not gonna choose this old one, which is 13 at the end. We're gonna use the second row that got updated, which is this one, Enzo 7, minus 4, 5, 0. And so we're gonna multiply by the multiplier, we're gonna get this one, and we're gonna subtract it from, we're gonna subtract the third row from it. Okay, this is the third row. We subtract it from it, as you can see, third row. We subtract it from it, just to make it clear so you don't get confused. This is the third row. Okay, this is the third row. We are subtracting it from the modified second row, pivot row. Okay, And you got these, boom. Now after that, you got the 0, you got the 0, you got the 0. What are you gonna do? You are gonna try to find x, y, z, which are the values. I'm gonna show it to you. So we said in the beginning x, y, z. So each one of these values is gonna be x, is gonna be y, is gonna be z. I mean, you should know this basically. X, 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 y, 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 z, z, z. So now after you have it in this form, you're gonna do what's called back substitution. Okay, this is multiplied by x is 0, so we got x deleted. This is multiplied by y, 0. So we have 9 over 10 z is equal to 9 over 5. So you got z. Now you go here in the top, after you got z, you have z, and the x is multiplied by 0, you're gonna get y. Okay, you go at the top, you got the z and you got the y, you're gonna get the x. That's it. Now, what if he said the exact same thing, but he said partial pivoting? It's pretty easy, pretty simple. I'm gonna just show it to you. You're gonna basically, when you start, you started over here, okay? Let's say this is your matrix. You're gonna look, what is your pivot? My pivot is 3. You take absolute value of 3, absolute value of 9, absolute value of 6. After you take the absolute value, which is the biggest value? 9. You're going to switch this and put it on top. So now you switch the original matrix and put row 2 to the 1 and 1 to the 2. You start solving, okay? Then after you reach, like after you solve, okay? This is very important. You do the swipe and directly you start solving. You got this 0, you got this 0. Now you move to the second pivot. Is the second pivot biggest thing or smallest thing? Because here it's the biggest, okay, you're gonna not gonna swipe any rows. But let's say that let me talk to Claudia 1 second. Okay, I talked to Claudia, he gave me this matrix. Let's say that you solved, you got this 0, you got this 0, okay? Now that you reach the second pivot, you're gonna take absolute value of what? Only the pivot row and under it. Okay, you're not gonna say 3, 1, 4. No, this is not correct. You're gonna take absolute value of the pivot you have, which is 1, in any row under it, 4. So what is the biggest value between absolute value of 1 and absolute value of 4? It is 4. So then you're gonna swipe this third row with the second row and the second row with the third row. And after you swipe, you're gonna solve as we explained in the previous Gaussian navy way, and you're gonna make this 0, and then you're gonna make the back substitution. Okay, so we finished with this. Since here we got 2 as the biggest one and 5 as the biggest one of absolute values of all of these, like the absolute value of 0 to 0. Okay, and then what's the biggest value of these 3? You're gonna say it's 2. The absolute value of 5 and 0, what's the biggest between these two? 5. So no need to swipe. No need, because pivots are biggest entry in the code. Okay, now that we reached the final question, we got the system of linear equations for to solve it in LU decomposition. You get the coefficients as we talked about before, 4, 8, 1, 4, 8, 1. You put him here in the matrix, okay? Then you got the lower matrix. It's called lower because you have the value at the bottom. Then you put ones in the diagonal and zeros at the top. Then you have the upper matrix, which gonna put the upper values at the top and zeros in under, okay? How are we gonna find and solve and find x, y, z using LU decomposition? That's what we are trying to do. We have some formulas that's very important. I hope you stop and try to understand them, okay? And maybe memorize and write them, of course. So AX, what is AX? A is this coefficient matrix. In X, when you multiply it by X, X is like X1, X2, X3, which is X, Y, Z. By the way, you have to know multiplication of matrices matrices pretty well, or multiplication of 3 by 3 by a vector 1 by 1. Okay, you can watch YouTube for these. So when you say 4, okay, 4x, you're gonna get 4x. Minus 8y, you're gonna get minus 8y. 1z, you're gonna get 1z, and so on. So what we're trying to say is basically all of this. A of x, okay, is gonna equal to b. B is this answer, okay, this answer. All of this column of answers is called b. After we do that, okay, we're gonna say, okay, one second. We're gonna say, okay, we have another rule that says A equals to L times U. Okay, so this means we can basically delete all of that and just write over here L U. So we get this formula, L U X equal B. Okay, so the first step you're gonna do is find L U, as we talked before. Okay, you're gonna find L U. How you find L U? You start by finding you start by making these zeros. Okay, you start by making these 3 zeros as we talked before. After you make these 3's as zeros, do you remember the multiplier we divided by over here? These beautiful, I don't know if they're beautiful or not, but these values, this is called multiplier, this is multiplier, this is multiplier. Okay, remember these? You're gonna get now here, okay, you're gonna take these multipliers and you're gonna put them after you found this. You have the upper already, you got it. Okay, you solved it by the way before, the navigation elimination. Okay, now you put the values of each one, the multiplier of each one. Multiplier of this is this one and this one. Okay, the multipliers for each one. See, this one, this one, this one. Okay, so after you put the multiplier, you're gonna put the multipliers down and you're gonna add ones in the diagonal and 0 in the top, and bam, you got the L. Now after you get the L, you get the U, you have these two in the formula. You got the L, you got the U, you are trying to find the X, and you have also the B, the answers. Okay, what you are gonna do, you're gonna say, okay, let's take these two, okay, the U and X, okay, and we're gonna say they are gonna be equal to D, because as you know, when you multiply any two matrices, it gives you new other matrix. Okay, so you're gonna say, okay, we have U and we have X, and if we multiply this, it's definitely gonna give us a new matrix. Let's call this matrix D. Okay, so after we call this matrix D, we can say L, we can say basically, what the hell is this? Say basically L D is equal to B. Okay, why would we do that? Because we already have L, we already have B. Now we can solve and find D, and if we found D, we already have U, we will have D, then we will get X. Okay, let's see how this works. So this is L, by the way, that we're talking about, and this is the D that we're talking about, A, B, C, the 3 unknown values, D1, D2, D3, and this is B, the answers. Okay, so you're gonna take this, which is the L, okay, and multiply it by D, and you're gonna get the B, the answers. Okay, oh, now we can use something called forward substitution. Okay, he wrote it already here anyways, forward elimination, I'm sorry, or whatever it's called. You're gonna say, okay, if I say 1A, it's gonna be 1A plus 0b is going to be 0 plus 0c is going to be 0. So 1a is going to be equal to minus 21. So we got the value of a. Okay? Then, after you got the value of a here, you're going to do the same. You're going to use the value of a, and you're going to get the value of b. As you can see, minus a plus b, and the c value already deleted by the 0 because you're going to say 0 multiplied by c. So you already have the a, you have this, you're going to get the b. And after that, you already have the a and b. Okay, you're going to get the c. So you got the c. All right, now you have basically found D1, D2, D3, or A, B, C. You found the D. You're gonna go and say, okay, U X is equal to D. U, which is this one upper, X, which is what you're trying to find, is equal to the answers. Sorry, equal to D, to the value that we find, minus 21, 2 over 2, 77 over 2. And you're gonna do the same thing, but this time it's not forward, it's backward because it's from down. Because you have two zeros here, 0 is gonna kill the x, 0 is gonna kill the y, so it's gonna be 0 plus 0 plus this z. Okay, this z is equal to 77 over 2, so you got z. And you're gonna do the same exact thing going upward because you got already z. Okay, this z you have it. And here the x is deleted, so you're gonna get the y. And now you got xy, zy, you're gonna get the x, and you solve it. So yes, put like, and I hope you get full mark, and good luck.